Hello everyone. Today we're going to be talking about air masses and fronts. So you're going to want to make sure that you have your foldable that we started in class and that it's all set up with different fronts on the tabs and then the middle insert already put in there. All right, so make sure you're all set up. And at any point during the video, I would recommend pausing or rewinding to make sure you get everything that you need because I'm going to be moving kind of fast as we go. So just make sure you're keeping up and pausing when you need to. All right, so we're going to start by talking about air masses. So first of all, what is an air mass? Air masses are just large bodies of air that have the same temperature and humidity. So on your sheet, you're going to notice that the very first sentence at the top on the insert on air masses asks you to fill in what characterizes air masses. It's temperature and humidity. Right? Those are the two things that define an air mass. And an air mass can be very large. They can be thousands of miles in diameter. They can cover large regions, and they're usually named for where they form. So if an air mass forms out by the water, it's going to have higher humidity. If it forms over land, it's going to have lower humidity. If it forms near the equator, it's going to be warmer. If it forms up by the poles, it's going to be colder. So that's why they tend to name them for where they're sourced, where they actually were formed. So we're going to take a look at the different types. This here is just an example of two air masses and where they might meet. So this obviously is a cooler air mass that's coming from up north. We've got a warmer air mass coming from the equator. And we're going to talk about what happens when two different air masses come together, because that's something that's very important for what we're studying about weather. So types of air masses, they can be named for forming in the Arctic regions, and those tend to be the very coldest air masses that you'll find. They can be called polar air masses. Those are formed slightly lower than the poles, but in that area, still at very high latitudes. And then tropical air masses, those are the ones that form right by the equator and tend to be warmest. And they can also name them for whether they formed over water or land. So they'll either call them maritime, and they have high moisture content because they've formed over the ocean, or they call them continental air masses, and those are the ones that form over land, tend to be a little bit drier, less moisture content. So as we go, you're going to fill in your table in the middle there, and you're also going to fill in your map with the different types of air masses that we're talking about. So we're going to start with maritime tropical. So you can kind of guess from the name what the humidity and temperature are going to be like. If it's maritime, it's forming over the ocean. Humidity is going to be pretty high, so you're going to have high moisture. And then it's tropical, so it's going to be warm temperature. And the symbol that you use for them is always a lowercase for the first letter and an uppercase for the second. So maritime tropical, lowercase m, uppercase t. So you can go ahead and update your table with that information and also update your map. So maritime tropical air masses are going to be the two down by the sides forming over the ocean close to the equator. The next one we're going to look at is continental tropical. Again, you can kind of guess just from the name what's going to happen here. If it's forming over the continent, it's going to be pretty dry. The temperature is going to be warm because it's tropical, and then the symbol is going to be lowercase c, uppercase t, and that's going to form in the United States right around here is where you tend to get continental tropical air masses forming. It's a warm area, it's over the continent. Notice that this map is showing air masses that affect the United States. That's what we're kind of focusing on here. There are others around the world, but these are the ones we care about for weather here. Maritime polar, that's going to be forming closer to the poles. You can kind of guess it's going to be colder. And since it's maritime, it's going to be fairly high moisture. So you can update your table there. High moisture, cold. It's going to be lowercase m, uppercase p. You can add that to your map as well. They're over here on the sides. Continental polar. Again, it's going to be dry, cold, lowercase c, uppercase p. It usually forms right around here in North America, up where Canada is. There's also maritime Arctic. You won't see that on this map because they don't tend to affect the United States, but they have high moisture and they're very cold, and they're a lowercase m, uppercase a. And the last one that actually impacts us a little bit, not very often, every now and then it'll make it down our way. It's continental Arctic, so it's going to be dry. It's going to be very cold, coming from the North Pole. And it's going to be a lowercase c, uppercase a. So go ahead and add that. That's the one way up top here. You can update your data table. Those are the air masses that affect the United States. So quick kind of check-in with air pressure, see if you remember this. Which air mass do you think is going to press down on the Earth more? Is it going to be a cold air mass or a warm air mass? Go ahead and pause the video, think about it, see if you know the answer. So the answer is actually going to be cold air mass, and that's because when air gets cold, it condenses, right? Air molecules condense down. They're going to be under more pressure, so they're going to be pressing down on the Earth more. And that's going to be important because when cold and warm air meet, because of this difference in density, different things are going to happen. So we'll explore that in a little while. So how do the air masses move? We've talked about this. Wind. Right? Wind is because of the unequal heating of Earth's surface, causes these convection currents, convection cells, and that difference in pressure is going to cause air to move, and that's going to push these air masses across the Earth in different directions. In the United States, we tend to have our air masses moving from west to east, and that's because of the global winds prevailing westerlies, which we've talked about when we talked about global winds. So a lot of our weather will start out over on the west coast, California, and it'll make its way across the United States because of prevailing westerlies. Air masses tend to get pushed towards us. We tend to get that weather last. All right, so we've talked about what an air mass is. We've talked about where the air masses come from, and whether they're dry, moist, hot, cold. We've talked about how they move a little bit. Now we're going to look at what happens when they collide. And this is what we call a front. Fronts are where air masses meet. So at this point, you're going to want to make sure that you have your flaps all set up. And on the outside of the flaps, as we go, you're going to be adding the map symbol for each front. And then on the inside, you're going to be writing three things, three pieces of information. You're going to need how it forms, right? So forms when. You're going to write the type of weather that it brings. And you're also going to, with those little cutouts, add the image that represents each front. All right, so as we go, make sure you pause and you're able to add those things. So first, just looking at what a front is. Like I said, fronts are where the air masses are meeting. And when they meet, different things are going to happen because of the different temperatures and densities that they have. Just like air masses, fronts are named for which air mass is moving. So whatever air mass is moving is going to dictate what the front is called. So for example, a cold front. The cold air mass is going to be moving into the warm air mass, so they call it a cold front. A warm air mass, warm air, is going to be moving into the cold. Right? So we'll take a closer look at each of these. These are kind of the four main types of front. So cold front, go ahead and add that symbol to the front of yours. It's going to be a blue triangle symbol. This is what you'll see on weather maps for cold fronts. And then how it forms. They form when cold air masses push under warm air masses and force that warm air to rise. Because cold air is denser, it's going to push underneath that warm air. The warm air that's less dense is going to rise up above really rapidly when this happens. And it's going to look something like this. So you're going to want to find the image that looks most like this. The cold air moving, warm air rising quickly above it. And this is going to cause thunderheads and violent storms. And the reason that is that the cold air is moving in so quickly, pushing the warm air up so quickly that the warm air is going to really quickly cool, condense, form big clouds that are going to then rain down very heavily. So you'll get really quick, intense, violent storms, and then as soon as they pass, the weather kind of becomes mild and a little bit cooler because of cold air mass has moved in, but it tends to be better weather afterwards. Warm front, that's the symbol for warm front. So little half circles that are red, so you can add that to the front flap. And then they form when moist warm air moves into cold air. So when this warm air mass hits the cold air mass, it kind of gently slides up and over it. So it happens much slower than when the cold front hits warm air mass. The warm air mass is going to move much, much slower. It's going to look something like this. Right, so it's moving up and over the cold air. The direction of movement is in that direction. And because it's moving a little bit slower, you still get rain, but it tends to be more of a gentle, light rain or snow, depending on the temperature, because it's rising up and over, it's cooling, condensing, creating clouds that kind of sprinkle rain down. And then afterwards, you're going to have, again, mild, nice weather. It's going to be a little warmer, though, because this warm front has moved through. Next one is a occluded front, and that's in purple. And you're going to have alternating triangles and half circles for an occluded front symbol. This is what you'll see on a weather map if you have an occluded front. So this forms when a warm air mass gets caught in between two cold air masses, and they push that warm air mass up. So it's going to look something like this: the two cold air masses, warm air mass in between, getting pushed upwards. And this is typically going to bring really strong winds and heavy precipitation. And this is because the temperature drops really quickly. That warm air is forced up. It's occluded or cut off from the ground. So it's pushed up really, really quickly. And because it's high pressure rushing in, you get strong winds. And that warm, moist air is going to create clouds and condense, and you're going to get some heavy rain. So strong winds, heavy rain with occluded fronts. And then finally our stationary front, that's the symbol. You've got red half circles and blue triangles alternating. How it forms when warm and cold air meet and neither air mass has the force to move the other. So typically they're just kind of either moving very slowly or not moving much at all. They just kind of sit there at a standstill. And it'll look something like this. And that's going to bring maybe fog, maybe a little bit of rain or snow, but it's probably going to lead to days of clouds and precipitation. So it's just going to kind of sit there because it's not move much. So stationary fronts tend to bring bad weather that just stays for a while and doesn't leave. All right, so those are the four major fronts that you'll usually see on a weather map. The other thing that you can tell when you're looking at a weather map is what direction the front's moving in, because they actually point in the direction of their movement. All right, so for example, if we had a cold front moving in here and it showed up on the map like this, we would know by the direction it's pointing that it's going to move down towards Florida, and Florida is probably going to experience some cold front weather if it continues to move that way. So you can make predictions looking at weather maps that way. All right, so I'm going to stop here. We are going to be starting to talk about how you can make predictions and read weather maps, but right now you just want to make sure that you've completed filling out your air masses and fronts. Once this is all filled out, you're all done with this assignment, and we'll move on to looking at weather maps and making some predictions next. All right, have a great rest of your day.